back to the Haking channel. So today we're going to be doing expanding brackets, which is one of my favorite topics in algebra. I know teachers say, oh, I love this subject and I love this topic, but I really do like expanding brackets and I really do enjoy linear equations and graphs and algebra. That's probably one of my favorites, which I'm sure you all know what my least favorite topic is in math, but now don't quote me on that. Okay, so today's learning intention is to be able to expand brackets, which I'll explain what does it mean to expand brackets and how we can do that, and what signs you might not see when you expand brackets that you need to know to solve. So today's success criteria is you need to be able to you need to know how to expand brackets. You need to be able to expand brackets using the distributive law. And today we're also going to be exploring how you can expand brackets using areas of a rectangle and repeated terms, which I will show you some worked examples as you will see that in your textbook. So just an introduction to expanding brackets. Expanding, or you could say eliminating or getting rid of the brackets, all right? It involves the expression being written without the brackets. So when you write the bracketed portion by the number allocated outside the brackets, so you might not really get that. But that's fine because we're going to look at this little example that I've just attached. So over here, this is the question. 2 open bracket A plus B close bracket. I'm not really going to say open bracket and close bracket later on in the video. I'm just going to say bracket A plus B bracket because it's going to take too long. And I'm probably going to get a tongue twister because I already feel like I'm getting one in this video. So you're probably wondering how this came about. So what this is saying is that there's 2 lots of the A and 2 lots of the B. That's why there's 2 A's and there's 2 B. I just wrote A plus B twice. So A plus B, that's the first time, and A plus B, that's another time. So that's twice. So A plus A is 2A and B plus B is 2B. Why? There is actually an imaginary 1 in front of every letter by itself. So if I wrote X plus Y, for example, there's actually an imaginary 1 in there. We just don't write it, okay? If I wrote X plus X, there is an imaginary 1 there. So 1 plus 1 is 2, and you write their best friend. You could say they both have, you could say they both have the same hairstyle. So 1 plus 1 is 2, and you got to add their hairstyle to them. It's part of them. Okay, so think of this as like A's are the ones with, I don't know, red hair, and B's are the one with green hair. Okay, so red hairs, green hairs. Now, that's one way you can expand a bracket. The second way, which is mostly used, is that you multiply each term. So what you do is you get the outside bracket and you multiply it by the first letter that it comes across, so 2 times A, okay, that's the first one, and then you do plus 2 times B, okay, and that can also give you 2A plus 2B, all right. We always need to remember that the symbol that joins a number and a pronumeral, or fancy word coefficient and pronumeral, is a multiplication sign. Okay, but we don't really like to see that in math. We like to see it really nicely without the multiplication sign, which is why we prefer this sort of answer over this one. Okay, so we wouldn't write that as the answer. We would write that one as the answer. Now I'm going to go into it in more depth, so don't worry if you didn't get it in the previous slide. We're going to keep repeating what we're learning. So this is the distributive law, and this is how we can eliminate brackets through expansion. So over here, okay, A times B, okay, equals AB, and A times C equals AC, okay. So the imaginary sign that joins them is multiply, You must remember that if they have numbers in them, they won't be like next door to each other. So for example, if I had 2 and 1, it would be 2 times 1, which is 2. Okay, you would not write 21. You wouldn't put the A value first and then the B value 1 next to it. That's not right. You'd have to multiply it together to give you 2. All right, that's something that I've just noticed, and I'm saying it now so it doesn't get repeated. So this is the same concept, A times B, but it's minus A times C, okay, because there's a minus. And we need to know that in front of every letter or number that doesn't have a minus or negative sign, it's always assumed that it's positive. And the rule that we need to know for signs is we must remember positive positives equals positive, minus negatives and negatives equals positive, and a positive and a negative equals a negative. Sometimes you might hear me say plus and minus because I get a bit I'm in a rush and I just say that, but it's positive and positive, okay, and negative. All right, so we just need to remind ourselves of this rule, which you'll carry all the way up till, I'd say, you need it for a long time in high school. Okay, so over here we've got how we would solve 5 times 27. So the way we do that is we can split the 27 up into 20 plus 7, and we can use the distributive law to multiply. So like I said, it's 5 times 20, not 520. Yeah, like up above. So 5 times 20 is 100 plus 5 times 7, which is 35. So why is it a plus here? You might be wondering. Well, there's a plus 7. Think if the sign belongs to 7. Okay, belongs to him. Okay, this plus sign belongs to C. This one belongs to C. So what sign would be in front of B? Well, I didn't see a negative, so it's given that these ones here are positive. Okay, I'll just do that over green. So when I multiply A and B together, how I know it's a positive is because positive and positive is positive. Okay, as I've done here. But over here, okay, A is a positive and C is a negative. So positive, negative is negative. That is why when they combine, it is negative, because this came out of a positive A and a negative C, which gave negative. Okay, positive and negative is negative. And that's what we really need to remember. All right. Now, this is just an example to help you multiply big numbers by separating them and using the distributive law. So now we're going to touch on how we can use equivalent expressions using an area of a triangle. So you'll see these three rectangles. Okay, so write 2 expressions for the area of each rectangle shown, one of which includes brackets. So over here, we know that the area, I've actually pre-typed this, the area of a rectangle is length times width. So actually, if I was to write the formula, it would be area equals length times width, like that. Okay, so the length, okay, it doesn't matter which way if I do width times length at the moment, but because it doesn't matter. It's like saying 7 times 2 is the same as 2 times 7, okay? They both equal 14. That's why I'm saying length times width is still the same as width times length. So what I've done is area equals, okay, let's say this is the length and this is the width, all right? Length, which is 6, times the width. Now the width you've had to plus both 7 and x. So 7 plus x, that's the width. This is the length. So to solve for that, you need to go 6 times 7, which is 42. And then you had to go 6 times x, which is 6x, because I told you that the symbol that joins a coefficient and pronumeral is a multiplication sign, but we don't write that. Okay, so in your answers, you need to, for this question, you need to show one showing that you've worked out using brackets, and then you solve the brackets by expanding. So over here, area equals length times width. So we could say this is length, this is width, for example. So we could say length, width, okay, to multiply. So 7 times 5 is 35, and then 7 times r is 7r. Okay, now remembering, we do need to remember the rule of positive negative equals negative, because if that was a negative, okay, if the question was 7, 5 minus r, it would be 35 minus 7r, okay, which is different from a plus there. So we really do need to remember to look at our signs very carefully, because if we want to get into the habit of practicing them so we're quite confident later. So in C, we can see that area equals length times width, once again for the rectangle. So the area, let's say, of this is A plus 4, and B, which is width, is 6 plus B. So if we were to multiply it, you might be saying that's quite confusing. What I've done is I've done 6 times A, okay, which is 6A. Then I've done A times B, which is AB, and I'll just change to a different I'll change it to a different letter another time. So 4 times 6, which is 24, and 4 times B, which is 4B. Okay, so I've just color coded them for you. Now, what you need to do is you need to be able to rearrange the algebra expression in alphabet order. So as you can see, I've got my A first, then I've got anything else with A in another letter second, then I've got the letter B, and then I've got the answer without no letters last. So I wouldn't really want to see that. I would want to see this order. Okay, that's the order that, and yes, it does matter, because in the future when you do nonlinear equations and quadratics, you do need to be writing your expressions in alphabetical order. Okay, so now we're going to be expanding these brackets. All right, so I'm just going to quickly show you what they are. So 4 times B and 4 times 7. So 4 times B is 4B, okay, plus, because there's a plus here, plus is plus, so plus 4 times 7, which is 28. So if I was to show you the working out to do that, I did 4 times B plus 4 times 7. That's that's how I would have worked it out. So over here, 9 times K, okay, all right, and over here, okay, was 9 times negative 5, okay, so that was 9K minus 45. That's how I worked it out, because there's the sign in front of the number or letter belongs to them. So over here, the minus belongs to 5. That's why I've done that. 5 times 2p, okay, and then we've got 5 times 5. You could write plus 5 if you wanted to, but because there's two signs, it might confuse you, and I just don't do that. So 5 times 2 is 10, and they're hairstyled P, all right, and 5 times 5 is 25, so I write 25. Now, what's the sign in front of any number or letter that doesn't have a minus? Plus. Okay, that's what we need to, that's why I didn't want to do it here. I just wanted to show you how to do it. So over here, okay, so 9x times 3z, and then 9x times minus 2. That's what I've got here. See how my my x pronominal and my multiplication sign is different? That's what we need to do. I do my z's like this sometimes because it can easily get confused as a 32, so I just do that. So we go 9 times 3 is 27. Now x comes before z in the alphabet, so it will be xz to combine them. Okay, and 9 times 2 is 18. Positive, because there's an imaginary positive here. I know it's positive. I could write one there to help you. Positive and a negative is a negative, because our rule positive, negative equals negative. positive, positive equals positive, and negative, negative equals positive. So using that one there, we know that it's negative 18 and the coefficient x. Okay, so if I was to rewrite that nice and neatly, it would be 27xz minus 18x. Okay, but because this one here has an x by itself and that has a z, I would expect it to be written as negative 18x plus 27xz. Okay, because we want the letter that goes before the alphabet first. And the reason why this one comes second is just because it has a z, and z comes after x. It's a good habit to get into. Promise you won't regret it if you get into the habit now. Okay, so that is all for today. And hopefully you have learned something about expanding brackets. It really does take practice. Remembering the rule, which is positive, positive equals positive, minus, minus equals positive, positive minus equals minus. It does take a bit to wrap your head around that when you see values and coefficients and pronumerals. I'll give you that. So cut yourself some slack in remembering that from the get-go. But yeah, you just need to keep practicing and hopefully do lots of revision and your extension booklet. Okay, thank you. Bye.